Alright, so we're just going to make a bit of a jump from expanding to factorizing using the highest common factor. So that's what HCF stands for. When we're factorizing using the highest common factor, what we have to have a look at is all our terms. So our terms at the moment are 25x squared minus 10x and 5. Now the question we have to ask ourselves with this is, what is common between 25x squared and minus 10x and 5? It's not really appropriate at this stage to look at the individual terms. So for example, there's a commonality between 25x squared and 10x, but we have to incorporate the whole equation in this sense. So if I was going to ask you what's common between 25x squared minus 10x and 5, you would say the number 5. So the HCF in this case is equal to 5. And the way we factorize this is by writing the highest common factor outside of the brackets. So we get 5 brackets, and if we take the 5 out, in other words we divide by 5, what we get is 5x squared. The next side will be 2x, and this next one will be 1. It's important to keep in mind that when I say taking out, that means divide, because when we expand, we're using the inverse operation again of multiplying. Let's look at the next example. So taking that into mind, what is common between minus 4xy, common between 12x squared and 16x? So the number 4 would be popping into your mind right now. But generally, when we're taking the highest common factor out, what we want to do is we want to factor it in such a way that we take out a negative as well. So I'm going to take out a negative 4. And what else is common between them? We have a factor of x, but in this case, it doesn't seem like that we have a factor of y that's common between all of them. So we're going to leave it at that. That's going to be our highest common factor, minus 4x. So if I take a minus 4x out, I need to divide all my terms by minus 4x. And if I divide that by minus 4x, what I get this is as y. This next term will be 3x squared. Oh, sorry, I do apologize. 3x, and the next term will be plus 4 in that case. So you can see that that's the fully factorized form. Now, if you look at the last example, once again, we have to have a look at what our highest common factor between these terms are. So what is common between this term, and this term? It doesn't look like by first instance that there's any numbers that are common between these two, because 13 is a prime number, so that it can only be 13 and 1. So we don't have to work out the numbers in this case. Let's look at the letters. This has x to the power of 5, this has x to the power of 3, and x to the power of 4. So what is common between all those terms? Well, the letter x is, but how many of those x's? X to the power of 3 in that case. Now let's have a look at the y's. Y is common, y to the power of 3 and y to the power of 2. How many y's? Well, in this case we only just have 1. So this is going to be the term outside of our brackets, and what's going to be left after we take out x to the power of 3 y from all of these terms? What we get left with is 2x squared minus 10y squared, and the last one will be minus 13x, and the last term will be y. So you can see here that when you expand this again, you should indeed get the same expression as the question. So this will become 2x5 y minus 10x cubed y to the power of 3 and minus 13 x to the power of 4 y to the power of 2. So just keep that in mind as well, that the opposite or the inverse operation of expanding is factorizing. So if you want to double check your answer, factorizing. If you want to double check your answer, make sure that you understand the relationship between these two. if you're unsure, expand your answer again and see if you come up with the original question. If you come up with the original question, you've factorized it correctly.